Alrighty, doors are shut, so I might as well get started. So, passwords are dead, long live passkeys. Although obligatory, this is me slide. Any PHP developers in the room? Anyone going to put their hand up at all? Well, I'm a PHP developer. I've been doing it for 20-something years. I love PHP. I use Laravel. I do Laravel and PHP security stuff. Laravel is the best web framework on the planet. I'm just going to put that out there. Talk to me later about it if you disagree. Laravel is awesome. Anyway, moving on. All right. So what are passkeys? Why did I fly across the planet to talk to you about passkeys? Because if you haven't figured it out from the accent, I come from Brisbane, Australia. So, it's a bit of a flight. But that's not really the right question. It's not really where I want to start. I actually want to say what's wrong with passwords. Because we can't really talk about passkeys and go, here, use this shiny new technology without understanding why we want this shiny new technology. Otherwise, we're just making some new thing and then it's some extra complexity, some extra step, right? So instead, we need to start with what's wrong with passwords. Because from a technical point of view, passwords are actually really, really good if you think about it. Like a password is a randomly generated unique string of sufficient length. And so when you have a randomly generated unique string of sufficient length and you pass that around as an authentication method, you can't really guess it, you can't predict it. And so when one system passes it to another system, you know that the person who's giving you, the thing that's giving you the password, got the password from somewhere and is allowed to do what it's trying to do. And when you add in rate limiting and other controls like that, the system over here can't really be trying to guess the password. If it's sufficient length, it's randomly generated, and you've got rate limiting in place, you can't really guess the password. It's just not possible. And so from a technical point of view, passwords are absolutely fantastic, and they work really, really well. There's one itsy-meetsy tiny problem with passwords. Humans. Humans are the weakness in passwords. And that's why we need something different. So what are the problems with humans? Why are humans the weakness of passwords? First of all, humans are forgetful. Humans forget things, and so rather than trying to remember and having to remember, 10, 20, 50, 100 different randomly generated unique passwords of sufficient length, humans can't do that. We don't want to do it. We can't do it. We're not going to do it. So we're going to use easy passwords, passwords that we can remember, passwords that are predictable, passwords that are easy to come up with, passwords that are easy to figure out, because we can't remember complicated passwords. And humans are lazy. So humans are going to reuse the same password on every single website because, again, we don't want to remember 20 passwords, 50 passwords, 100 passwords, 200 passwords. Have you guys looked at how many passwords you have in your password managers? It's a lot of passwords. We don't want to remember all these different passwords, so we're just going to reuse the same password over and over again. And so we're reusing the same password that we keep forgetting, and so it's a simple password that we use everywhere. We're getting to the problem. Humans are also gullible. Problem with humans is you can ask a human for their password, and if you ask it in the right way, they will give it to you. So password security has gone out the window because ultimately you just ask the human for their password and they'll give it to you. It doesn't matter what the password is. If you ask in the right way, the human is going to give you their password. And there's all the security gone. You've got the password, you can do whatever you want, you can log in. And finally, humans are non-technical. So we're technical people, we're at a technical conference. Most humans are not technical. Most humans don't want to be technical, don't want to use technical solutions. Password managers are technical solutions. You have to install them, you have to configure them, you've got to use them, they just take effort. And most humans don't want to use a password manager because it's technical, it adds extra complexity. It's just too much for them. And so passwords don't work because in order to secure passwords, you need a technical solution, or you need to remember complicated things, you need to not be lazy and reuse passwords. So we came up with a solution for this, which has multiple names. You've got multi-factor authentication, two-step verification, multi-step verification, two-factor auth. I'm sure there are more acronyms and more names and terms for this. They're all roughly the same. There are, subtle differences between them, but ultimately they all mean roughly the same thing. And the fact that we have so many different terms and so many different acronyms for basically the same thing highlights the problem. They're all technical solutions to the problem. And so they all work on authentication factors. That's the whole basis for them, is rather than just having something that just having your password, which if, as we looked at before, humans are gullible. You just ask a human for their password, they'll give it to you. But what if you add multiple factors in so that it's not simply a case of asking the human for their password? For example, you've got something that you have. So in addition to something that you know, so you know the password or the PIN, also you have something physical with you. If I can find which pocket I put it in. This is my YubiKey. I don't know if you can see it, it's tiny. This is something that I have, and this is an authentication token. Or my phone, again, can be used as something that you have as an authentication device. And so in order to compromise that factor, that authentication factor, to meet that requirement, you'd have to physically come to me and find and get my key from me. You could probably just get a baseball bat and take it off my body once you knock me out. But the point is, you have to physically be in my location. If you're in my hometown in Brisbane right now, you couldn't get this from me because I'm in Oslo. We also have something you are as another factor, which is like your biometrics, like your fingerprint, your eye scan, your face scan, the way you talk, the way you walk, your handwriting, all these different things. And the benefit of that is that someone can't call you up and get your fingerprint over the phone. I mean, they could get your voice printer, I guess. But the point is that something that you have, something that you are, is different to something that you have and something that you know. And so there are multiple different factors. And multi-step verification, 2FA, all those different things, they all rely on using multiple of these factors to provide authentication. There's also a fourth one, somewhere you are. We don't really get into that much because websites, you're by definition logging into it from anywhere, so we'll ignore that one. So we started out with SMS-based multi-factor auth, which a lot of people, I don't know how many of you in this room have this view, but a lot of people have the view that this is actually lowering your security, which is complete rubbish. Because you've got a password, then you've got the SMS token. By definition, you've got two factors here. The only way it really fails is if it's like your password recovery thing, and that's a separate discussion we're not going into. So, looking at SMS-based MFA based on our human vulnerability factors. Forgetfulness, well, you don't have to remember anything, so it ticks that box really easy. Laziness, it ticks the box. You just type in the phone number and it works. You don't have to remember anything, you just get out your phone and And most people who use the internet are going to have a phone, and they're going to have, can receive SMSs, and so using that as an authentication method is really simple. Where it falls down is gullibility, because you can get this code from someone really, really easily. You just kind of call them up and ask them, or you go to their phone carrier and you convince them to give you the phone number. Then you can get their codes. But it is a non-technical solution, because most non-technical people, if they're using the internet, there's a good chance they have a phone and they can receive SMSs. And so non-technical people, SMS-based multi-factor auth is actually a really good solution because they can use it. It doesn't require any technical skills that they don't already have. Failures we've kind of already mentioned. These carrier swapping, MFA fatigue, and phishing. Easy ways to compromise this. So it's not really a good solution because you can easily get through if you're trying to. App-based multi-factor auth, so when you've got authenticator apps. Solves forgetfulness again. You're not having to remember anything. The app does all that for you, so that's great. Unfortunately, it doesn't solve laziness because it takes effort to set it up. You have to manually set it up. Like you create an account on a service, then you've got to go to settings and then security, and then you've got to configure your app, then you've got to get the app out and all those things. It just takes too much effort, so no one really wants to do it. So half the time you don't do that one. It's not like SMS, we just type in the phone number. Gullibility, same problem. Phishing website asks you for your MFA code, you'll type it in. If you don't realize it's not the legitimate site, if you don't realize it's a phishing site, you're just going to provide the code. Or realistically, you could just call up the person and ask them for the code, and the same way in SMS, they'll probably give it to you. It's also a technical solution because you've got to scan a QR code and use an app and go in there and there. And also, if you're registering for an account on your phone, how do you set up your authenticator app by scanning the QR code on the very device you're using to register? It doesn't work. It's a horribly complicated technical solution to the problem. And non-technical people just don't want to use it. Hence why they always go back to SMS-based multi-factor auth, because it's easy. The same failures here as we've seen before, except for lose your phone, which is a big one. And a boss I used to work for, his GitHub account, he can't access it because his phone got destroyed. And he had app-based two-factor auth set up to it. He didn't set recovery codes, didn't have any keys on it. GitHub won't let him into that account because he doesn't have the codes from the phone that got destroyed. So it's not really a good solution because you've got that gigantic failure at the bottom. Hardware tokens like YubiKeys or your phones, they solve forgetfulness, kinda. When I did this talk I did it in Austin, Texas in November. And this little thing here, I accidentally left at home in Brisbane. So I forgot this and I couldn't use it. So it kind of fails on forgetfulness because you've got to remember to bring the little thing with you. You can sometimes use your phone as a hardware token, which generally you won't forget as much. But still, it fails that one. Kind of. Laziness definitely fails this one because you've got to set it up. But the same way that app-based multi-factor auth, you've got to go in and configure the thing and figure out how to set it all up. Sometimes it just takes a lot of effort. So who's really going to do that? Do you really spend the time to do it? Also, do you really want to have to find your key every time you log into the service? I mean, I usually use app-based rather than hardware tokens because it's easier. Solves gullibility though, because it's linked up with the domain name and you can't really ask for it over the phone. Your phishing sites just won't work with them. So it does solve that problem, which is nice. But it's still a technical solution. You need to get some extra hardware thing or configure the apps or some other complicated process that normal people just don't want to do. It's expensive, you've got to buy the physical thing. So, it costs money. Physical device, as I said, device compatibility as well. So your device has to support it. So it doesn't really work. It has a bunch of problems. Good technical solution, but not a good non-technical solution. Biometrics, final one, is solves forgetfulness. Yes, you can't really forget your fingerprint, so that's nice. Laziness, this is a tricky one because some apps make it really easy to use biometrics. You tick a box, but that's generally like when it's on your phone. On your computer, it's probably more extra steps, even if you have biometrics on there at all. So it's not really good because you have to enable it and configure it on each device you want to use it on because it doesn't sync. Gullibility, well, it solves that one in the same way that hardware tokens do because it's linked to the domain or the app or that sort of thing. You can't really phish it over the phone as much. I guess voice prints possibly, but ignoring that side of things. Your biometrics, generally, like your fingerprint on your phone, that can't be phished, so that's nice. But it's still a technical solution because you've got to configure it on every device. It's not synced across devices, and you need a device that supports it. Modern phones, yes, will do it. They'll give you your fingerprint, but does everyone's laptop have a fingerprint reader or have the facial recognition camera in their laptop? I guarantee there's at least someone in here who doesn't have one of those on their laptop. There we go. Or your desktop at home, does it have any of those things? So it's not really a good solution for that in the non-technical point of view. I kind of covered all these. Oh, that's right, the other thing yet. So tied to a single device, and because of that, it's optional. Which means that if you're trying to compromise an account that has biometrics on it, you just find the way to authenticate without biometrics because obviously there has to be one for the user to be able to log in on a system they haven't logged in before because biometrics are tied to a single machine. So it's not really a good solution. So you probably see where this is coming, not where this was going. All of those things just don't work. And ultimately, they all still require passwords. They all still have the vulnerability of passwords in them. So we need, where has it gone? A different solution, which should be pretty obvious given you all came to the talk called Passkeys. But anyway, that's kind of where we're leading for this, is we need a better solution, which is Passkeys. All right, so Passkeys. This is the definition on the FIDO Alliance website. Based on FIDO standards, Passkeys are a replacement for passwords that provide faster, easier, and more secure sign-ins to websites and apps across a user's devices. Unlike passwords, passkeys are always strong and phishing resistant. Passkeys simplify account registration for apps and websites, are easy to use, work across most of a user's devices, and even work on other devices with physical proximity. So all of that basically to say that passkeys are an attempt at providing a user-friendly, non-technical solution to the password problem. I like the fact that they're going for a word like passkeys rather than something incredibly complicated like WebAuthn, because it's designed to be user-friendly and easy to remember. Non-technical people are likely to remember passkeys. It's related to passwords, but it's different. But it's still easy to remember, and it's a word that could easily be used. And so a lot of the work in Passkeys, from what I understand it, is around wrapping up existing and new technologies in a user-friendly way to try and provide a non-technical solution to the problem. So let's start with some demos so you have an idea of just how Passkeys work in the real world before we look at some of the more technical aspects of it. And hopefully this is going to work because demos are always fun. Okay, so can everyone, yeah, that looks big enough, should be good, right? So this is a great demo site. If you want to try out Passkeys, passkeys.io is the best demo site that I found for it. So the flow for Passkeys covers both registration and authentication, rather than just like a step you do after you register, but it's actually part of the registration flow itself, which means that it does replace passwords and authentication. So the first step we would do to register for an account, so on this website, it's taking an email address in the box. You could accept anything in here. I think it's even optional. You probably don't need to put any username or email address as an identifier. You could just register for a passkey directly. But if the website wants to contact you via email or things like that, then of course you'd have it there. And when I click continue, it's going to go into the browser and then the Windows dialogues. So all the dialogues following after we go through the confirmation screen is going to be based on the laptop from Windows itself, which means that every different site you use is going to have the same dialogues, which give consistency, and that which goes towards making it easy for users rather than every site implementing their own different flow. I just want to explain that now because there is a timeout on some of these things. So to register for an account, I put my email address in, go continue. It's going to say no account exists. You want to create one? Yes. This is just all part of the demo site itself. Then create a passkey. So this is when we start the passkey flow. And it's going to go here. So this is a Windows dialog for Windows Hello. And it's saying, use a device to sign to passkey.io. Going to go, OK. It's going to authenticate me. Come on, we can do the face. It's going to work for me. Fantastic. I'm going to go OK. It's going to say it's saved. I'm going to go OK. We now have an account. That's how simple passkeys are. Cool. And so there's no passwords involved, none of that extra stuffing around, no password managers really, at least none of the extra steps you normally do for a password manager to create a new account. It was just automatically done in Windows, and so it's set up using the Windows Hello system. And the benefit, as I said before, is that because there's common screens, you'll see that on any site that you're registering a passkey from, you'll see those same dialogues. All right, so now we have an account. I'm going to log out, and I'll show you logging in, the logging in flow. So sign in for passkey, click on that one. Chrome up here is going to say use your passkey. So stephen@valoransecurity.com from Windows Hello. Continue. It's going to verify it's me. Is that going to work or is it going to be painful? There we go. There we go. Now we've authenticated. So authentication flow was a couple of clicks, no passwords, none of the extra nonsense. Really, really simple. So that's the benefit of passkeys. That's what we're trying. That's what they're trying to get to, is to make it just really easy and user friendly. And you can see that non-technical people, they're going to. I mean, the first time they go through that flow, they might try to wonder what's going on here and there. But the fact that every single site would use the same flow makes it a familiar process. All right, so just rename this one so it's a bit more clear because they do use annoying words. Windows. Okay, so that's my Windows Hello passkey. And the thing about passkeys is you can create more than one. You can create multiple passkeys for different accounts. So what I'm going to do next is, I'm going to show you logging in on different browsers. So this is a guest browser in Chrome on my laptop. If I switch over to this one, this is my other browser. So this is still Chrome, but this is a different account. So it doesn't have any of my cookies or settings or anything else. It's a different account here. But if I click on sign in for passkey, it's going to go back to the same dialog and it's going to see if there's a passkey in Windows that I can use. So click on that one, you're going to work. Oh, hello, 1Password. I'm not up to using you yet. There we go. Okay, so here's the same Chrome dialog and it's found this passkey from Windows. If I go continue, and it's going to ask me to authenticate. The fingerprint reader's decided to stop working. It's okay. Alrighty, now I've logged in, completely different browser window. I'm using the same passkey. All right, so as I said before, we can have multiple passkeys. So now I'm going to make a new one. I'll go back in here, create a passkey. And here, and what we're going to do, rather than use Windows for the passkey, I'm actually going to do one on my phone. So I'm going to go use another device. And the benefit of this, the way they've set it up like this, is so that if you're going into a new device that you don't already have an account on, don't have your passkeys on, then you can actually use an external device like your phone for your passkeys. So I'm going to select here the Android device one, go next. It's going to give me a QR code. Then on my phone, I'm going to go to the code scanner, scan the code. It's going to say use passkey at the bottom. Go continue. Confirmation thing, connects to my device. So it's using Bluetooth to connect to my laptop. My phone is saying create a passkey. Would you like to create a passkey for passkeys.io? I'm going to go continue. Use my screen lock to verify that I am allowed to do it. My laptop now says passkey saved. And now we have a new passkey in the account here. So I can change that to Pixel. So now I have two passkeys in this account, and the second one, the Pixel one, is actually on my phone. It's linked to my Google account on my phone, which means that if I go into my browser on my phone and I have the passkeys.io app on here, all I have to do is go to the sign in for passkey button, click on that one, click on the account that I just created, use my fingerprint, and then it's logged me into the same account that's on my laptop. Well, because it's set up to seek the passkey over the Bluetooth connection there. Now, my demo, when I did this back in November, So Android 14 supports, supposed to support third-party passkey authenticators. And I have 1Password on my phone and my laptop. And so when I did this demo back in November, it worked really well. I used the QR code, it went into 1Password. So 1Password set up my passkey, which then automatically synced to my laptop, and then I used 1Password to log in on my laptop to show the syncing. However, for some reason that's broken. And so Android is no longer letting me use a third-party passkey authenticator. And so I'm stuck with a Google one on here. So there are some hardware limitations at the moment. So passkeys are at the moment a technical solution. That's the goal, is to make them non-technical and to solve these problems, but it's still something that's being worked on and developed. So, you know, demos don't always work. But yeah, so cool. So that's that one. So now I have a passkey on Windows, and my Windows passkey isn't syncing anywhere. It's just locked in my Windows. My passkey on my phone is linked in my Google account, which means that other Google, I think if I had a second Google phone, I think I'd be able to use it, but I've just got one, so be it. The other thing I can do is put my passkey in 1Password, which has a really nice flow. So if I go back into this one, so this is my other browser that has 1Password. Oh, thank you. I was worried it was going to ask me to type a password, and that would be entertaining. All right, go away. All right, so 1Password is now logged in. So if I go create a passkey, then 1Password is actually going to ask me if it wants to save a passkey, so I'm going to go save. And 1Password have a really, really nice implementation of passkeys. So now that I've got that in here, this is the first one's the 1Password. If I sign out, and then as soon as I go to the page, 1Password notices it and options gives me the option to sign over passkey immediately. So all I have to do when I'm logged into 1Password is click on the sign in button, and it's actually going to automatically log me in. Really, really simple. And if the Android implementation was working, then it would have synced to my phone, and then I could do that on my phone, and it would all be magic and perfect, and it would be a beautiful demo. Unfortunately, Android broke something, I don't know what. So anyway, so we now have an account that has 3 different passkeys set up on it in 3 different for 3 different devices, so I can log into this account easily. And if I used someone else's laptop and to go to this site, all I would have to do is open up the QR code, scan it from my phone, and then I could log into the passkey on their thing. So I could probably just demo that now quickly. I think I've got plenty of time. Go away. All right. So, no, use the other browser, get rid of 1Password. All right. So I'm going to go down in here, sign out. All right. So back on this page, we're not logged in. And if I go to sign in for passkey, I want to use a different passkey. And I'm going to ask you to use a phone, tablet, or security key. Goes to Windows, so I'm going to use another device. All right. So QR code scanner. Actually, I'm going to do this. So because Windows is already paired with my phone, if I just click on that one and go next, it's going to connect to my phone. My phone has a notification to verify that who I say I am. And then I'm going to tick on that one. And then I'm logged in. And so the benefit of that is that if I'm using a friend's laptop or a shared laptop or a new laptop, a device that I don't control, I can use the passkey on my phone, and all of the sensitive stuff stays on my phone. And so there's nothing compromisable ends up on a laptop. One more quick demo thing to show is GitHub have a nice implementation of it. So if you want to start using it now, you can check out GitHub. So on the login screen, you've got sign in for passkey. Just click on that one. Just go to Windows, continue. My fingerprint is not going to work. Making sure it's you. Okay. And there we go, straight into my GitHub through the passkey. So it makes it really easy to log in that approach. All right, back to the slides. So hopefully the demo gave you an idea of passkeys in action. As I said, they are still a technical solution because they're still being implemented and there's still compatibility issues. But the end goal, and you can kind of see where it's going from the demos and things, is getting towards a non-technical solution. So the goal with passkeys and what they were trying to solve, there were 3 main factors, 3 main goals, I guess, that we're trying to solve with them in order to consider them replacing passwords and being a good solution. First one is speed. So they have to be faster than typing a password. Because if you think about it, a user going to log into a website, if it takes them longer to log in using passkeys than it does to type in their password, then why are they going to do it? They're just going to keep using their password. There's no point in adding extra time into that. Now, I did highlight typing because if you use a password manager, it's a really fast process. But you did notice that when I was using 1Password, for example, the passkey sign-in was just a single click and it just worked. So it is very fast. So I think they solved the speed factor. And as the UI is improved and Windows, is a bit clunky with the Windows Hello, but when they improve those interfaces, it'll make it much faster to log in. So the speed of logging in and even registering an account will be much better with Passkeys than you've got having to figure out a password. There's also convenience is an important one. So it needs to be able to sync between devices. And I kind of mentioned this before, is that the point of Passkeys is that rather than being tied to a single device like a hardware token or your biometrics or your old style biometrics, your passkeys need to be able to sync between different devices. And so you set up a passkey on your laptop, for example, and then it's available on your phone so that you can log into your accounts on your phone and on your laptop, any other device, really easily. And also the backup QR code as well is there so that you can log into a new device or a different device without using your passkey as well. Because unlike passwords where you can just manually type it in on your computer, you can't do that with passkey. And so they have the QR code and the Bluetooth connection to allow you to connect to set up, use your passkey on any other device securely using that setup, which solves the convenience problem. It makes it easy to use on any device you're trying to use. Obviously, as long as it's compatible with passkeys, but that's a thing that's coming. And finally, it has to be secure. Your security is the important factor here. We're replacing passwords. It has to be something that's more secure than passwords. So they love using the phrase phishing resistant rather than saying you can't phish it. And I guess it's fair. They don't really want to come out there and say you can't phish it at all. Maybe there's a way, but in generally, it's pretty difficult. I mean, passkeys are tied to the domains and the apps, and a phishing site isn't going to be able to use your passkey to steal your credentials to log into another site. It's just not possible in my current understanding of how it works. And likewise, you can't really call someone over the phone and convince them to give you their passkey. Like, how? There's no way you could give that information over the phone. So it's resistant to phishing, which solves that problem. And the other one, and I've got an asterisk here, is they say there's nothing to steal. And what they're talking about here is the applications you're logging into. So if you think about data breaches, all these different sites that you've created accounts on, when they get breached, if someone gets access to the database, the information that gets stored for a passkey, which in this case is a public key, and we'll get to that shortly, you can't do anything with because it's a unique public key for that application. So if you steal their public keys, you can't do anything with it. It's completely useless. Unlike passwords, where if you steal a password from here, then you can use that password to log into every other account the person has an account on because they've reused their password. But you're probably noticing that the asterisks and also about syncing before, and by saying nothing to steal, we're only really talking about the applications you're logging into. Because if my passkeys are being synced from my phone to my laptop, then they're going via something. And so there is something that you could compromise to steal the passkeys. And that is a real concern, something that I'm interested in. But the thing is, your passkey providers, the companies that actually manage your passkeys are Google and Microsoft and Apple and 1Password. And we're talking about companies that know security, companies that have a lot of resources to put security into this and that are going into being a passkey provider, knowing what they have to do. And so to be able to compromise one of those and steal the actual passkey data that could be useful is going to be a significant effort. And it's going to take a lot of, it'd have to be a major failing on one of their parts in order to expose this information. And so, unlike 1,000 different websites with weak security that don't really understand security, all the different applications to log into, having to protect your data, you've got the big companies like Google and Microsoft that are protecting your data, and they're pretty good at it. They know what they're doing. And so, in terms of security, it's putting security where it should be in the responsibility of those companies. So I think it ticks that box as well. But I do question their nothing to steal thing. It's not entirely true. And it's funny they go for phishing resistant, but nothing to steal. It's like, you're not quite absoluting on one, but you're absoluting on the other where there is so bad. So we'll go back to our original factors, our weaknesses from before. Forgetfulness. Do passkeys solve this? Yes, because there's nothing to remember. When you set it up on your system, you set it up on your phone, your laptop, and it's just there, no passwords. They solve laziness too, because as you saw with the registration flow, it's part of the flow. It's no longer an additional thing you have to configure. It's just there. When you create an account, when you register an account with a passkey, it's just part of the flow. It's just easy. So laziness is ticked. Solves gullibility. We've talked about this before. You can't really steal it. It's hard to phish it. Or possible to, I don't know. It's phishing resistant. I'll use their phrase. And I'm cheating a lot here. It's non-technical is the goal. At the moment, I think it's still a technical solution. But the goal is for it to become supported across everything so that it is a non-technical solution. The non-technical people can use the device they already know how to use passkeys. And if you think about it, logging into your computer, you know how to use, if you're using Windows, you know how to use Windows Hello because it's how you log into Windows. On your phone, you know how to use your fingerprint scanner because it's how you log into your phone. And so passkeys use that exam login thing. So I'll save the questions at the end. Very curious what you're thinking. So the non-technical people know how to use these tools. And so it should be a non-technical solution for them because they're already familiar with these things. And that's the goal anyway. All right, so these are some failures at the moment. Limited platform support, so your devices need to support it. And as we saw in the demo, it is a little bit clunky and things like the 1Password syncing broke because there is limited support in syncing it and the different applications. And that's just something that's going to come over time as more systems support it. And it does take time to add support for things like this into applications and into hardware. Also limited app support. So there are limited apps that actually support it. So you can't just go out and use passkeys for everything now. You can only use it on the sites that are currently providing it. And also it's still optional. Because at the moment, because not everything is supporting passkeys, you still need a way to log into the account without the passkey. And so if you want to attack my GitHub account, for example, although I've got a passkey on there, I've still got a password on there. I've still got, app-based MFA. And so if you can get my password and my MFA token, you don't need my passkey. You're into my GitHub account. So it's still optional. So it still doesn't solve that problem yet. Here's a compatibility chart. Showing where we're currently sitting with the different things. As you can see here, the iOS is doing quite well. macOS is doing pretty well. Ubuntu, not very well at all. Windows is planned and coming and things are happening there. Android is this little one down here, is it? This little one down here I think should be a red tick because it broke my demo. Thanks, Android. But yeah, so as you see, it's coming along and it's good that these things are planned and being working on. So it's still in progress. And this is from a great site, passkeys.dev, which has a lot of implementation information and other compatibility charts and things. So check that out if you want to go more info. Passkeys.directory is a great site by 1Password. Where'd it go? So 1Password have a list of the sites they know do passkeys. So if you want to play around with this and use it on different applications, you can check this out. And check the sites that you use, like Google, you've got on here, Kayak, Microsoft, Nintendo, blah, blah, blah. A whole bunch of different sites. So check this out if you're interested. It's Passkeys.directory. And they've also got a vote for passkey support thing, which I'm guessing is just kind of a shaming companies into supporting passkeys by having them high up in the list. I love this. 1Password is number 4, and this directory is provided by 1Password. So, yep, anyway, it's coming apparently. I don't know. So yeah, it's quite a fascinating list. So that's that directory. So yeah, check that out if you want to play with passkeys now. GitHub have a really nice implementation, and it actually ties along with their push recently to require multi-factor auth on all developer accounts, which I think is a great idea. And so adding passkeys into that is going to build security because we really need to protect our code. And GitHub is such a huge repository of code and of the internet is running off GitHub essentially, and so we really need to protect it. So how do they work? What's the behind the scenes? So hopefully you can see this. It doesn't look too bad actually. The screens are nice and big. All right, so this is the registration flow. So this is what happens when you're creating an account on using the passkeys. All right, so so the authenticator over here. This is like the passkey app that you're using. So like your phone or your laptop. That's the thing that stores your passkeys. The client is the browser or the user working together. And then application is the application you're logging into. So we start out by the user initiating a registration ceremony here. So this is basically when you browse to a website and you say, I wish to register an account. And the website returns the configuration to the client and it says, okay, here's the configuration you should use to create an account on this service, which includes things like what sort of keys you want it allows and that sort of thing. And then it sends that straight over to the authenticator because it's the authenticator's job to deal with all that. So the authenticator, first thing it does is it checks the client, it checks the user is actually allowed to register an account. He's actually allowed to work with Passkeys. And you'll saw in the demo, Windows Hello kept asking for my face or my fingerprint. It was verifying that I was there. Likewise, my phone was doing my fingerprint as well. And so that's doing the user verification and user presence checks, checking that I'm allowed to be there. And the presence, and I guess we've got the multiple factors because the passkey provider is my phone, so it's a physical device something I have, and then it's checking my biometrics, something that I are. So when the authenticator is happy that the person using the phone is the one that is allowed to create passkeys, we get over to here, and the authenticator then creates a public-private key pair. And this is the important bit. So what it does here is it creates a public-private pair and sends the public key to the client. The private key never leaves the authenticator. It stays in the authenticator the entire time. And so then public key goes over to the client, which sends it to the application over here, and then we're done. And so the application stores the public key. And then as far as the application is concerned, that is the user credential. That is who the user is. And as long as, and that's all it needs to know about. So this is kind of like the password that it stores, only unlike a password, it's a public key. And it doesn't matter if it gets compromised because you can't do anything with it without the private key. And the private key stays with the authenticator. And Eli did a great talk about public-private key encryption. Yep.
When you're saying authenticator in
Yep.
this diagram, is that the phone, for example, your phone, is that the phone as an entire device, or is that the hardware token that lives within your phone?
I don't know exactly the answer to that, but I think authenticator in general is like the device itself, like the whole phone.
So
yep.
It's not a private key that is living within the hardware, the
No.
platform hardware token. It's living on the phone outside that secure.
Yeah, it would have to be because it's synced. So the question was, is the private key locked on like a hardware chip or a hardware token on the device, which can't be accessed? But no, the private key does get synced, and that's what's synced as part of the passkeys. So it has to be in the software. Yep.
Yeah, question. You said that it doesn't matter if the public key gets compromised.
Yep.
It doesn't matter if it gets leaked, but if someone can change the public key to their own for your account, you can log in with their private key, right?
Yep. Yeah, great question. So the question was, it doesn't matter if the public key gets compromised, but what if someone can change the public key? Can they log into your account? And the answer is yes. So on the authentication slide I'll get to in a sec, we'll see what the public key does. And yes, it's exactly that the public key is important for verifying who you are, but having the public key doesn't help in terms of a data breach. It's the same way, unlike if you steal passwords from an account, then you've got passwords you could use elsewhere. Okay, so that's authentication. We'll get to that in a sec. So I think we've covered this one, haven't we? Yeah. So the public key goes to the registration, and the application keeps that, and that's what it uses to identify you as a user and links you with the passkey that you've created, which is the private key. So the authentication flow starts out pretty similar. The user initiates the authentication ceremony, and then the application provides an authentication challenge. So we've got that down here. So we wrote to the website application, and it provides the authentication challenge. This is basically a thing saying, if you wish to log in, here's the challenge. Here's a bit of information you need to work with. We go to the authenticator, and we've got the same verification step here, where it checks for the user presence, user verification. So that would be, Windows Hello checking for my face, or fingerprint on the phone. It's the device checking that the user who's using it is allowed to be using that device, and is allowed to access the passkeys and, as such, the private keys. So then we have down here, we've got authenticator signs the challenge using the credentials private key. The signed challenge is presented to the client. So what happens here is the private key that stays in the authenticator, that is used to sign the challenge. So the challenge that the application sends here, this thing here, is then signed using the private key. And so the signed challenge gets sent back to the application, and the application uses the public key to confirm that the signature on the challenge was generated using the private key. And this is the important bit. So the application has the public key, and it can confirm that the signature is valid based on the private key. Because the way the public-private keys work is that you can encrypt and sign things using either key, and then the other key can verify that the key did the work. And so by signing the authentication challenge using the private key in the passkey, then that signature, the public key is used to can tell you if that signature is valid. And if you don't have the private key, you cannot generate that signature. It's not possible. But also, if you have the public key, you can't generate the signature. You can only generate the private key. So if you steal the public key from the application, you can't do anything with it. You can't generate a signature in order to authenticate with the system. And because it generates a different public-private key pair for every single website, if you steal the public key from one application, it's completely useless on any other application. Yep?
Can I keep the private key somewhere, like in one password, so that if your phone gets stolen and you have an iPhone at home that you've never used for passkeys,
Yep.
could you still log on?
Yeah, so they're synced, and I'll get to that. Yeah. I don't think I have a slide on that, but yes, you're right. So the private keys in the authenticator are that synced as part of the passkey service, passkey provider that you use. And lost my train of thought. Yeah, so for example, 1Password, which I set up by passkey in, 1Password is keeping my private key. And this is why it's not stored on the hardware token on the physical device, but it's actually stored in the software. Because 1Password has my private key, which means that any device that I've logged into with 1Password has access to that private key. And so any device that has my 1Password logged into it can use that passkey. And the same thing that Google syncs it between their devices. So Windows at the moment doesn't sync. It's just stuck on Windows on the local machine. The idea is that will be syncing, but they haven't got that yet. Pretty sure Apple does sync between Apple devices though. And this is where where I was questioning the nothing to steal before comes in, because granted the public key is stored in the application and you steal the public key on the application, it's completely useless. You can't do anything with it. But the private key, that is being synced and moved around, which means that if you can compromise that, then you can get the private key. And if you get the private key, then you can generate your own signatures and you can log in. So that is the risk there. Yep.
So what you just mentioned is that the private keys could be compromised kind of in transit during sync.
Yep.
If they're stored in software on, say, my phone,
Yep.
if someone has access to my phone, can they recover private keys that live on that phone? If not, why not?
I'm gonna go yes. I'm guessing it depends on what you're using to manage your passkeys on your device. So yeah, I'm gonna say yes. I think.
It uses your account password to encrypt them, but I don't know.
I don't know the details of how they all work. I know that 1Password have been asked this question before in terms of just generally having your passwords and things in 1Password in your account and saying, what if someone's compromised your account and then you unlock your 1Password, can they access your passwords? Like, they're on your computer, they can watch everything you're doing, so they can probably access it via other ways anyway, even if there are memory leaks. So if someone compromises your device, then it's game over anyway. I think there's a good chance they can get your private keys, your passkeys, your passwords, and any other thing that's on your device if your device is completely compromised. So yeah, yep.
Okay. Do you consider this a substitute for passwords only, or both passwords and MFA? Or do you need MFA for certain extra?
No, in my opinion, it's replacing both. Because you've got, and it uses, this chart uses the terminal, where is it? User verification and user presence. And so what it's doing there is it's, you've got the two factors where the passkey is on a physical device that you have, so something that you have, and it's checking like your biometrics or your PIN or something, so it's something that you know or something that you are. And so the passkey provider itself, the passkey device, is responsible for verifying who you are using the multiple factors. So I think it kind of replaces both. I mean, if you're using a really high security implementation, maybe you'd want to use multiple things, but I think the point of passkeys is to replace all of that in one go. But if you're working on really high security, maybe you want extra steps. Yeah, it really depends on your risk, I guess. Yep.
So I'm hearing a lot of Google and Microsoft and big
Yep.
tech names in here. Just to understand the process correctly here, the authenticator is where the private key lives.
Yep.
So that can be your password manager, that can be 1Password, Bitwarden, whatever.
Yep.
The traffic that goes between the site and the authenticator is simply the challenge and the sign challenge in return.
Yep.
So if my private key lives in my password manager, then Google, Microsoft, whoever is not involved in that transaction in any capacity. It is only, it's only the business of the password manager.
Yes. Yeah, so the comment was about where the passkey is stored, and if Google and Apple and Microsoft have it, if you're using a password manager, and it's up to you as the user to decide where you want to store it. So yeah, if you're using a password manager like 1Password, then you can put all your passkeys in there, and then it wouldn't be in your Google account or your Microsoft or your Apple or whatever. Non-technical users who don't use a password manager would probably just rely on like Google or Apple to store their passkey, and it's up to you as to where you want to store them. I ended up having passkeys in multiple locations from that demo, multiple places. Like Windows had one, and then I had one in Google, and 1Password has there. But when you're using it, generally just pick one place and use that, and that would sync. Yep.
You say that this solves the gullibility problem, but if
Yep.
you were less technical, and
Yep.
I called you up and said that a message will show up on your phone now, please click OK, or whatever I know how it will do.
But that message, how would you do that message through passkeys though?
No, I would, if I wanted to go to a website that,
Yep.
that I know you have access to, and click
Yep.
on the login button, and say that, hey, use my phone for ID. And
Okay.
I have you on the phone and say
Yep.
that your phone will now ask for your thumbprint or whatever.
Yep. Yeah. Okay. So the question was phishing. You call someone up if you try to log in using their passkey, and you call them up over the phone and say your phone's going to prompt you. That doesn't work because it uses local Bluetooth. And so when I was doing the demo, use my phone as my passkey provider, it was doing a Bluetooth connection between my laptop and the phone. So the first time I did it, I used the QR code. So I had to scan it, and then that allowed the devices to temporarily pair in order to use the passkey. The next time I did it, when I selected my phone from the list, it had remembered the connection, but it was still using Bluetooth. And so it was still a local Bluetooth connection. So
To be in the hotel room next
yeah,
door.
yeah. As long as you got physical proximity, yeah. If I walk away from my laptop and you could convince me to approve the passkey login, and the screen would say you're logging into this account. So, but yeah, I guess okay, maybe this is the phishing resistant factor they've got there. If you can separate someone close enough from their devices to get the Bluetooth connection, yeah. There we go. What was that? Is threatening someone's life considered phishing? I mean, I guess so. I guess that's the answer to why they're saying phishing resistant, is because there is a way to do it. I'm glad we've sorted that one out. Cool, yep.
So if, say someone stole the public key and then they set up like a rogue website,
Yep.
would that website be able to handle the login and make it look like you're logging in?
So the question was, if someone stole the public key and then set up a phishing website, would that be able to do anything? And I don't think it would do anything useful. Passkeys are locked to like the domain name as well, so the authenticator would not use the private key because would be a different domain name. But also, what would that achieve? Because you still got to generate this challenge, and the problem is that if you've got the public key, what are you going to do with it? You could verify the signature based on the private key, but you're not the application you're trying to log into. The trick would be you'd have to sit between the application you're trying to log them into, and then pass the challenge through there and convince them to use the right private key to sign the challenge, then pass it back through so you can get the session. But because it's locked to the domain name, you can't phish the domain name unless you're on a really compromised network with certificates where you're faking the domain name. And if you're faking the domain name on a compromised network, then I think the user's got bigger problems. So yeah. I have no idea. I don't know how well it links up with the domains. So what are you thinking in terms of subdomain takeover?
Well, you would do the exact same attack vector that you've been talking about here.
Yep.
But you just compromise the subdomain. So if you're squatting on bit.shopify.com,
Yep.
and you want to shop on, generic.shopify.com, and that key is scoped to *shopify.com.
Good question. I don't know. I don't know if you can scope it to subdomains and wildcards like that. If you could, then maybe. It's an interesting idea. Yeah, I don't know. Sorry. I mean, I would hope that you couldn't do wildcard domains, but maybe you can. I think it's a risk. If you do allow that in there, I think that's a risk that you have to accept. Yeah, it's an interesting idea. any more questions about the flow? Actually, no, we'll go to this demo. This is kind of similar to what we just talked through. So this is WebAuthn flow. And so Passkeys, we use WebAuthn under the hood, which does the public-private key work, the challenges. This is a cool little demo that you can run with webauthn.me, which kind of shows you the moving parts and how things move around for the registration and authentication. It moves pretty quickly though, so I can't really narrate it while it's going, but it's worth showing and to give you an idea where the movement stuff is. So I type in my name as my identifier, and then I'm going to go register them. I'm going to see it moving through here as it goes between the browser, which is the web browser and the user. The relaying party is the application I'm trying to log into, and the authenticator is the passkey provider, which is Windows Hello on my laptop. Okay, register. So relaying party sends the challenge through to the browser, which then sends that to the authenticator. It's going to ask me to confirm who I am through Windows Hello. And you'll notice the little timer in the background is counting down. So there's limited time to do these things. So I create my passkey, and then it's going to send, come on, there we go. You'll see it's saying sending signature and public key raw ID and challenge back. And validate. So now we have a new credential. So this is the credential. This is basically our identity on the application we're trying to log into. Have the raw ID, what's called the raw ID here, and then here's the actual signature, so the certificate that was created. This is the public key that we've passed through to the application to log into it, and this is linked to the private key that's staying on the authenticator. So now we've registered an account. This is our credential that's used to log in place of, say, a password. And then to authenticate, we're going to say we're going to log in with this raw ID. So this identifies the public key that we're using, the public key private key pair that we're using to log in. So we're going to go click login, and then we'll see it moving through. That's the username in, and then it's going to send the challenge back through in the raw ID. So this is saying this is who we're expected to log in with this credential. Do authenticator, doing the face scan. Come on, and then it's going to go back. So now we've got the signature added to the challenge, which goes back to the application. Application says signature matches the public key, therefore we're logged in. So yeah, that's basically it. So this is a nice little demo. If you want to get a better feel for the flow and the moving parts, definitely check this one out. webauthn.me is awesome. And I think they've got a debugger and a few other tools in here as well, if you do want to learn more about this stuff. Cool. And just to finish up, there's a couple of useful links. So in terms of resources and things for Passkeys and WebAuthn in general, that top link there is one of those great GitHub awesome pages. I'm sure we've all seen those before. So check that out if you want to dive more into things. And there's a bunch of different packages and for different frameworks and languages in there as well. Passkeys.dev is a great site for like an overview of how they work and front-end code. So the JavaScript you need to implement it in different ways and how it's supposed to work, as well as like the compatibility charts and things. It's got screenshots from there. And then the two demos that I use are the ones at the bottom. Passkeys.io is great. It's the one I was using for the registration login flow. And then WebAuthn is the one I just showed you that has the moving parts internally. And that's it. So is everyone all good on this slide? Do we anyone need more time? No? Awesome. Well, thank you very much.